Hello guys, welcome back to a new video. And in today's video looking into very important topic, that is the compression factor. We are introducing a new term, that is the compression factor, and this is very important term, and this will help you understand the real gases as well as the ideal gases. And if you haven't checked out our previous videos, we have got a complete series on the gases. Have been on the ideal gases. We have discussed in detail all concepts of ideal gases, and this is the time, the compression factor is the time which will lead us to the real gases. Let's look into it. And today's video we're looking into the value of the compression factor in the cases of ideal gases. Gradually we will be looking the value of compression factor in the real gases and all that stuff, and after that we will be getting into the concepts of real gases. So you can say that this is the close-up summary of the ideal gases. So but this is very important, and the compression factor is leading us to differentiate the both. Okay, so as we know uh, that the ideal gas equation, today we will be discussing about ideal gas equation. In next video looking into compression factor based on the real gases. So in today's video just the simple one, the PV is equal to nRT. As we all know, this is the ideal gas equation. PV is equal to nRT, right? So for this, if you're gonna see that the value of R is constant, the number of N is also constant, and temperature is, if you what will you do is that P V upon uh, nRT. If you do this, what if you do this is equal to question mark. What will happen if you do this? Now uh, this will introduce a new term, that is Z, a new term, very new term, very important video to focus on it. If you move and divide the both sides of the values of the PV is equal to nRT equation, so we will get a factor that is Z. And here you're gonna see that if you move this according to mathematics, PV upon nRT, so the one which is left behind is this is 1, right? So can we see the value of the compression factor Z is 1? So let's prove this in today's video. Okay, so we'll be discussing about more conditions and what is the usage of the compression factor in the upcoming videos, because in today's video we're looking into the in ideal cases the compression factor is not that much important, like it is constant, as I will be proving it, while in the real cases plays a role. Okay, so PV is equal to PV upon nRT is equal to Z, and we need to prove that what we need to prove, we need to prove that this is equal to 1, and we are not known about it, right? So uh, let's put the values. We know that this PV is equal to nRT is at STP, right? We have got STP conditions, and we have discussed what is that STP. If you haven't checked those videos, do check them out. And the pressure in the STP condition, the pressure is equal to 1 atm, right? 1 atm. We need to mention the units, because if we want to get the unit of the compression factor, we need to write the mention the units. Maybe we do not get any unit, but I'm mentioning that P is the value is done. Let me take this one. P is done. Now it's time for V. 1 atm 1 atm multiply what is the V value. V is the volume, and that STP condition, that is equal to 22.4 dm cube. 22.4 dm cube, right? We have got upon values. Okay, so we have got upon values. The n value is in at STP we have got 1 mole, so this would be 1 mole, and the R value is like this. This is a huge value. 0.0821. Then we have got ATM dm cube, mole inverse and Kelvin inverse, right? Okay, so this is the value of R, and if we talk about the T value, that is equal to 273 Kelvin, right? Okay, so this being huge, but don't worry, uh, let's cut off the values. You're gonna see that mole and mole inverse will cut off, and Kelvin and Kelvin inverse will cut off, and ATM will cut off this ATM, and DMQ will cut off this DMQ. Now what is left behind? Okay, we need to prove that this is equal to 1, right? This is equal to 1. Now what's remaining? That is equal to 22.4 on 0.0821. And this is equal to 1. So here we have got equal to 1. Now this factor varies, and we have got the equation that this is proved that the value of z is equal to 1. This is proved that the value of z is equal to 1. So this was kind of the concept about the compression factor, and we have proved the value of z that is equal to 1. And meet you guys in the next video. Till that, goodbye.